This is Ben with question 42. Now, let me start off by saying that 42 is the answer because 42 is 42 and 42. So, let's go to the question. Which of the following graphs is the object's velocity versus time graph? Now, I couldn't make all these graphs because there are a lot of weird ones and a lot of weird things happening in them. So, you're going to have to bear with me and look at your own packet. So I'll give you some time to go get your own packet, and we'll be back soon. That should be enough time, right? Okay, yeah. Welcome back. So let's jump straight to graph A, and we can tell this one isn't it, because there's a slope and velocity. If there's a slope and velocity, that means the velocity is changing over time, which would mean there is a curve in the position time graph. I don't see any positions in any curves in the position time graph. And so there will never be a slope in the velocity time graph, which knocks out A and C. C also has a slope, which leaves it between B and D. Now, the only real differences between the two is that between the 0 and 2 second mark, the change in velocity is much higher for B than it is for D. And in between the 4 to 5 second mark, the change in velocity is much lower in B than it is to D. Now, if we look at the position time graph, between 0 and 2 seconds, let's say the slope is 1. And between the 4 to 5 second mark, let's say the slope is negative 1.5 or negative 2. Either way, it's steeper than between 0 and 2. Which would mean that the space between the graph and 0 on the velocity time graph is going to be much greater. So between 0 and 2 is going to be a smaller hole between the velocity and 0 than it is for 4 and 5, which means it's D. Thank you.